Okay, we're doing example from 5.1, and we're using rectangles to estimate the area under the graph. This is what we'll eventually be using integrals for. This is kind of our intermediate step. So we've got the graph x squared, and we're looking for the area between 0 and 2, and we're going to use the midpoint of each rectangle's base. So I've drawn this out. This is the graph y equals x squared, and you can see I have two rectangles here. If I can find my pointer, there it is. This one and this one. So here's my two rectangles, and I've got the midpoint. So the midpoint between 0 and 1 is 0.05, and this one is 1.2. That's where it falls on this. Now to find the height, we're going to use the function. So this right now, and again, I can't seem to keep my pointer here. So this is 1 unit long, right? So this is the width, because we're going to find the area of each of these. An area, remember, is just length times width. Nothing's changed. So the length here, if we're going this way, is 1. And then the other one, width, is what's going up. So here, when x is 0.05, so let's bring this up. When x is 0.05, that means we just put it into the function. What's y? 0.05, and we square it. 0.25. So 0.25. That's going to be how high this is. And this will always tell you endpoint, midpoint, where to use it. So we're here, and this is our rectangle. So this is the area of this first rectangle. So it is 0.25, so 0.25. So that's our first one. And now what we do is we add the second one. So this, again, is just 1 long, right? But this now, we're at 1.5. So we put 1.5 into our equation, so that means square it, and we're at 2.25. So this becomes 2.25. For some reason, I just cannot see my pointer today. So 0.25 plus 2.25 is 2.5. So our area, using two rectangles, is this. So let's go back here, and 2.5. Check the answer. And that's all there is to it. Now I'm not going to go on and do this mainly because I draw so badly, as you can see, but if you want to do this in 4, you just split this in half. So now instead of there being one, you'd have a rectangle, and I'm just going to overdraw this so you can see this. You'd have a rectangle here, and then one here, and then one here. The idea being the more rectangles you use, the closer it is, because each midpoint then would estimate a smaller area, and it would be closer to the actual area, because obviously this is not getting the exact. We can see the extra as we draw them. It's just an estimation. The more you use, the better it is. So obviously if you use 16 rectangles, you would have a better estimate than 2, and so forth. So you should get a little bit better as you go on to the next one. But this gives you the gist of how you do these problems.